Hello guys, today our topic is relative atomic mass, which we generally call as RAM, RAM, and also we will try to understand what is atomic weight, RAM and AMU and U. Rather than going on to the terms, first we have to understand the concepts, how these things came and what brought about these changes to express the relative atomic mass with certain units and atomic weight with certain units. So, let us make a deep dive into the system, correct. So, see, first of all, when you talk about an atom, the atom consists of protons, neutrons and electrons. Okay. So, let us take a atom like sodium. Okay. So, sodium consists of 11 proton, 12 neutron and 11 electron. So, necessarily sodium atom will have the mass of atom equal to the mass of the particles that is present in the atom, right. So, protons has a mass of 1.67 into 10 to the power minus 24 gram. Neutrons had the same, almost 1.67 into 10 to the power minus 24 gram. Electrons has the mass of 9.1 into 10 to the power minus 31 kg. So, I will multiply it with 10 to the power 3. So, it will be 28 gram. So, if you see the masses over here, there are 11 electrons, I will multiply with 11. If you see the masses of electrons, it is very less than when you compare it with proton and neutron. So, necessarily you can basically ignore this mass. So, this mass can be ignored, the electron's mass can be ignored. So, if you ignore this mass, then you will see in between these two, you can take this 1.67 into 10 to the power minus 24 as common. So, 1.67 into 10 to the power minus 24 as common and you will get 11 plus 12. So, you can write it as 23 into 1.67 into 10 to the power minus 24 gram. Looks a very cumbersome numerical value. When I am going to say you what is the mass of sodium atom, I have to say this much amount of thing. So, whenever these things happen, we try to reduce it. How do we reduce it? We reduce it by changing the standard of the units. So, what we did is, we defined 1 AMU as 1.67 into 10 to the power minus 24 gram. Okay. So, this part can be written as 1 AMU, that is AMU. So, that is why mass of sodium can be written as 23 AMU. Okay. So, this is the atomic mass or the atomic weight of sodium, 23 AMU. Clear? Atomic weight of sodium is 23 AMU. Now, sometimes you will be seeing that this is written in grams and things get really confusing because AMU and gram is definitely not the same, correct. So, during those times you need to have your concepts crystal clear. So, as we have taken sodium as our example, so we will go with sodium everywhere. So, for sodium we have got it that atomic weight is 23 AMU. Then what is 23 gram? Creates a lot of problems. So, 23 grams cannot be the unit of or the weight of one sodium atom, it must be something else. So, 23 gram is nothing but it is mass of a certain number of sodium atom. And this number is same for all the elements. This number is same for all the elements. How is it so? Please understand very carefully. बहुत easy है. So, see, number of atoms in 23 gram. How do I find out? So, one atom is 23 into 1.67 into 10 to the power minus 24 gram. Clear? So, number of atoms in 23 gram, what it will be? See, each atom weighs this much. Okay. So, let us take this value as 1 gram. Okay. So, each atom weighs 1 gram. Now, I give you 23 grams of atoms. So, how many atom is there? 23, because each atom weighs 1 gram. How did you calculate it? Total weight by weight of one atom, correct? So, total weight is 23 gram divided by weight of one atom, that is this one. When you calculate this will come out to be 6.02 into 10 to the power 23. This is a number, because both is gram, gram cancels out, no units, number, okay, number does not have any unit, and this number is basically Avogadro's number, and this is constant. This is constant. How it is constant for everyone? Okay, let us just check whether this is same for magnesium atom. So, if I calculate for magnesium atom, it has 12 number of protons and 12 number of neutrons. So, total is 24. So, definitely 24 into 1.67 into 10 to the power minus 24 gram is the magnesium atomic mass, that is mass of magnesium atom. Okay. Now, when I recall that what is, sometimes it is written that the atomic weight of magnesium is 24 gram. So, similarly you have to calculate the number. Total mass is 24 gram. 24 gram divided by 24 into 1.67 into 10 to the power minus 24 gram. Again gram cancels out, 24 cancels out, and the number comes out to be 6.02 into 10 to the power 23, and it is same for all other atoms. Okay, you try doing it, excellent exercise, all other atoms it is same. Okay. So, when we talk about atomic weight and they call it in units like grams, what exactly can we call them? See, for sodium 23 gram is mass of 6.02 into 10 to the power 23 atoms. Okay. This number of atoms has a mass of 23 gram. 23 AMU is mass of one atom. Okay, clear? This mass many times is also mentioned as gram atomic weight. So, atomic weight necessarily is a misnomer. When I use it as gram, it should be mentioned as gram atomic weight or gram atomic mass. Okay, and also you can say this as molar mass, that is mass of 1 mole of a substance. What is 1 mole? 1 mole means nothing, just Avogadro's number. Okay, this where I have written over here mass of 6.02 in 10 to the power 23 atoms. Here I have written mass of 1 mole of atoms. So, that means 1 mole I can, rather than writing 6.02 in 10 to the power 23 atoms, I can write 1 mole. Okay. So, this is what it is, 23 gram, 23 AMU. Now, coming to the last part, this one and this one. What is RAM? Relative atomic mass. Relative atomic mass. So, that is RAM. Clear? So, what is it basically? See, whenever people try to calculate the atomic mass for one atom, the numbers came in points and all those things. Those were getting difficult. So, sometimes people ask that I want to express the atomic mass, but I do not want it to have an unit like AMU or an into 10 to the power minus 24 and all those stuff. People do not like that, right? I am pretty sure neither me or you guys are going to like it. So, what they did is they made it relative, that is ratio. So, how they did it? See, they took an atom. They took an atom, or you can take a, okay, what do you want to take? You take a cake. So, this is a cake. Divide it into 10 parts, or rather 4 parts. Let us make it simple. 4 parts. 4 parts which are equal. 4 parts which is equal. Okay. Each part can be called as 1 unit. Each part can be called as 1 unit. Okay. And so, if I give you the whole cake, then how many units of cake you are getting? 4 units, right? So, whole cake over here is 4 units. This is the concept of U. Okay. First of all, they took one cake like this. They took an example of, let us say, hydrogen. So, hydrogen is atomic number 1, mass number 1. So, they made it 1 unit only, and they created atomic mass for all other elements. How they did it? So, first they took hydrogen, okay, atom of hydrogen, and suppose you want to calculate the mass, the relative atomic mass of, say, oxygen atom. So, weight of one O atom divided by weight of one atom of hydrogen. They calculated the relative atomic mass of oxygen. Clear? They calculated the relative atomic mass of oxygen. Clear? No problems. Once they have calculated the relative atomic mass of oxygen, they get a value, say x. This x is called RAM. So, if the 1 unit of cake over here is weight of one atom of hydrogen, and let us take this weight came out to be 8 units. So, 8 by 1. So, how many units? 8 units. Okay? In this hydrogen is 1 cake, and I give you oxygen atom which has 8 such cakes. So, oxygen's weight is 8, hydrogen's weight is 1, 8 by 1, you can write that 8 unit. Okay. So, they did it with hydrogen as a standard. After that, they did it with oxygen also. Finally, in 1961, UPAC is International Union of Pure and Applied Chemistry. Okay. So, in 1961, UPAC made a universally accepted scale, that is C12. So, the scale was carbon 12 scale. So, they took a carbon atom like this, divided into 12 equal parts. So, 12 units were produced, right, and each part was 1 unit. So, whenever I am talking about, say, magnesium, which is 24. Now, if I want to calculate RAM of magnesium, so weight of one atom of magnesium divided by 1/12 of weight of one atom of C12. Clear? So, this is what it is, and I have to take the weight of magnesium. So, what it will come? Weight of magnesium, you also know, weight of magnesium is 12 times of this, sorry, 24 times of this. 1/12 of one atom of carbon means 12 divided by 1, 24 times. So 1/12 of carbon atom is 1 unit. Then magnesium will be 24 units. So that is why this RAM from that time onwards was mentioned as 24 units. So actually at this moment of time AMU cannot be used as per UPAC's latest recommendation. You should use U rather than AMU. Okay? So UPAC said if you write relative atomic mass, then do not write AMU because it is unitless. Gram by gram, okay, weight of one magnesium atom divided by 1/12 of weight of carbon atom, both is gram by gram. How can you give an unit to it AMU? AMU is a proper unit, guys, you cannot use it. So rather than UPAC said, please give a unit to it as U, and that is accepted one. Okay. So nowadays AMU should not be used. However, in certain ICSE books AMU is used and certain schools do follow. So if your school teacher says you to follow AMU, please do that. Do not go into an altercation with anybody because that was also correct. Nowadays UPAC has said do not write AMU. So this information must be percolated. Write U. So we will write U. Relative atomic mass we will write U. Okay? RAM unit we will write as U, and U is basically unified mass. Okay? So basically U is units. Now suppose one apple is getting sold at 2 rupees, whatever it is, and I am naming that one apple as 1 unit. Okay? If you go to any shops, when you see the bill, suppose you are buying 5 set of books, same book for your friends. Okay? So they will write the price of one book and they will write 5 units. That means one book has been taken as 1 unit. Okay? They will write 5 units. Your total 5 books, 5 units. Similarly for atomic mass also they are doing the same thing. RAM is basically the ratio of 5 books by 1 book, so 5 units. Here there were 24 books by 1 book, so 24 units. So this is the fundamental of U, AMU, atomic weight and relative atomic mass. Okay guys, I think you understand this lesson, and later on definitely ask questions if you have any problems with it. Thank you.